like 2 or 3 weeks we're like proving all this stuff.
All this stuff. Okay, so actually, everyone, you might be impressed because my proof is just so much better than all the other proofs out there. Ready?
Okay.
Let's do it. First, it involves knowing things about parabolas. You guys have probably just forgotten like everything, right?
Yeah, that's actually so
Excellent. So I'm gonna do like a 1-minute recap about parabolas. So it's like this. There's this thingy, and then there's like stuff. So this is the origin, and then this is the vertex, which we place at 0, q, and then we have the directrix down here at y equals negative q, and the parabola looks like this. And what is true? How did we derive the formula for the equation of the parabola? We said that any arbitrary point x comma y is such that the distance to the focus is equal to the distance from the directrix. And when you set up that equation, you end up with like y equals 1 over 4q x squared. Okay, is that good enough of a reminder? Good. All right. So now the proof. I will do it for the for a vertical parabola in standard position. So let's take the parabola y equals 1 over 4q x squared. And I'm going to prove it for this guy, and then other parabolas are just the same thing but stretched out or possibly moved over or axes switched, but it's basically the fundamentals are pretty much here. All right, well, I'm going to make a giant picture now. Yeah, no. Okay, so here's the vertex of the parabola. Here is, try to draw this thing semi-correctly. Put this here. This is your, how much time do I have left?
4 and 3 minutes.
Oh, that's not good.
Whoa.
Okay, here's my quite terrible parabola. Quite really terrible, actually. Oh well. And here is my directrix, maybe. This is the line y equals negative q. Okay, and now what I'm going to do is I'm going to pick an arbitrary point on the parabola, and I'm going to call it A. And if I call it A, then I know that its y-coordinate must be 1 over 4q a squared. Agree? Okay, and now I am going to connect these 2 points. And I am going to draw the tangent line to the curve at that point A. So I'll draw this tangent line. So looks something like that. Ooh,
Yeah.
Bad picture. Okay. Great. All right. So, what's the equation of that tangent line? This is the part where calculus is needed. Yeah, you just do the power rule, right? If we have a function f of x equals 1 over 4q x squared, then its derivative is
1 over 2q
1 over 2q x. Agree? Okay, so what is specifically the slope of this line?
1 over 2q.
Yeah, just a over 2q. Okay, that's pretty awesome. So, I will write the equation of this line. The equation of this line is y minus 1 over 4q a squared equals a over 2q x minus a. Okay, where is all this going? I would like to know what this point is. What is this point right here? 0 comma what?
Plug in 0 to the line.
plug 0 in for x, right? Yeah. So when x is 0 in this line, what is y? Can we do this in our head? I get negative a, let's see, I get a squared over 4q minus a squared over 2q. Do you agree? Okay, so that turns out to be negative a squared over 4q. Okay, negative a squared over 4q. Okay, well, we're running out of time. So if that's q, what was the whole point of that? Oh man. So wait, watch. I can finish this in 1 minute. Drop a perpendicular here. What is this length from there to there?
That plus q.
That's q plus plus a squared over 4q. But also, it's true that this is that also. It doesn't look the same, but it is, right? This is a squared, this is a plus a squared over 4q, right? Because it's like, that's the y coordinate, then plus a little thingy. So yes. Okay, so these two are the same, but then by the definition of the parabola, these two are the same.
Wait, you wrote A plus B squared for B.
What was I supposed to write? Q. Yeah, sorry. This is Q plus. Okay, do we agree that this segment, we're going to be done in like 10 seconds. This segment has the same length as this segment, right? Even though it doesn't quite look like it. But then these two are congruent because by the definition of the parabola. So if I connect it, what kind of shape is this four-sided figure? Better than a parallelogram. It is a rhombus. It is a rhombus. And there is a fact about the diagonal of a rhombus. These guys are congruent.
Wait, what were we even doing?
And so, I'm explaining now. Since these two angles, that diagonal is an angle bisector, and that means that angle is congruent too, and that completes the proof.
Oh, we're doing that. Okay.
Yeah, I have proven that that's true by proving that those two angles are equal. Those two angles are equal because these two are vertical angles, and these two are congruent because it's a diagonal rhombus. Who gets it, basically? There's a little bit of rush at the end, sorry. It looks like a kind of a rhombus, but it looks like a crappy rhombus. All right. Good job. Names to run out of time even on a day when I was doing nothing. Record is intact. I'll see you all.
Just like
I'll see you all Thursday.